Hi everyone. Today we are officially starting our last chapter for AP Calc, and we're going to be starting looking at areas between functions. Now the good news is this is going to be really closely related to something you already know how to do. We're just adding kind of, I guess, another layer to it. So we already know how to find the area between two curves, right? Up until now we've practiced finding the area between a curve and the x-axis. Okay, so if I wanted to find this area between a and b under the curve f of x, we know we would take the integral. Our bounds, our limits of integration would come from here, so it would be the integral from a to b, and then we would integrate our curve f of x. And of course we'd have our dx at the end. So that's something we already know how to do. What we're working on next is finding the area between two curves. So something like this. Now I have a function y equals f of x and y equals g of x, and I want to find that area trapped in between. And here's really the big idea. We're going to use what we already know how to do. So I'm going to do f of x in blue. So the idea here is if I could look at just the area under the curve y equals f of x, right, over that same interval, right, we know that would give us this whole area, which would be too much, right, because I want to get rid of this. So what we're going to do is we're going to subtract the area, and I'm going to make this one, let's do green. If I make this curve green, so it looks like this, I'm going to subtract the area under that curve between A and B, right? That would be subtracting out this portion. And then what you can see is what I'd be left with is just that area in between. So that's the big idea here, is we're going to be subtracting out some areas. Now, when we work with these problems, we'll always call this one our top, and we'll identify a bottom function. And so the idea is if f and g are continuous functions with f of x greater than or equal to g of x throughout the interval from a to b, so in other words, y equals f of x is always on top, then the area between the curves between a and b, here's what we do. We take the integral from a to b, and for right now, just in general, what we do is we take the top minus the bottom, and we integrate that. So if I use my specific functions here, what we're going to have is a to b, and I integrate f of x minus g of x dx. Now, I should take a step back. Really what's happening is we're taking the integral from a to b of our top function minus the integral from a to b of our bottom function. But then we can use our rules of integration to write it as a single integral. So that's the big idea. We're taking the area between the top curve and the x-axis, and we're subtracting out the area between the bottom curve and the x-axis, so we're left with just what's in the middle. Now, the one thing I do want to bring up here is how come we've never talked about this top minus bottom before, right? When we did between the curve and the x-axis, we always just integrated the function. And here's what's really happening. If we think about this, the x-axis here, we know that equation is just y equals 0. So even though we've never really explicitly stated this, this is the same if we want to think of top minus bottom. Our top here is f of x. Our bottom was always just 0 before. And that's why when we were finding the area between a curve and the x-axis, we always just said it was the integral from a to b of f of x dx. So just connecting that back. We've really always been doing top minus bottom. It's just that our bottom was y equals 0. All right, so now we're going to go ahead and do some problems. Again, the idea is there's always going to be a very clear top and bottom function, and we're going to be finding the area in between those curves. So let's go ahead and do some examples. All right, so our first problem here says to find the area of the region enclosed by the parabola y equals 2 minus x squared and the line y equals negative x. And this is no calculator. So the first thing we need to do is make a good sketch, especially when there's no calculator. We want a really good sketch so we can clearly identify the top curve and the bottom curve. And we also are going to have to be careful with identifying our intersection points so we can find the interval. So let's go ahead here. Now, there's a couple ways, right, that we can go after this graphing. So I know this is a parabola, it's been reflected and it's shifted up too. But if you're not sure what that should look like, we can always just make a quick XY table. So I'm going to go ahead, this one's going to be in blue. So I'm just going to pick some points, some negative, 0, and some positive. So if I plug negative 2 squared is 4, 2 minus 4 is a negative 2. Negative 1, that squared is going to be 1, 2 minus 1 is 1. If I plug in 0, I get 2. Plug in 1 is 1 again, and 2 is going to give me that negative 2. So I'm going to go ahead, just scale this. All right, and I'll plot my points. All right, there we go. So there's one curve. And now we're going to go ahead and do our y equals negative x. So I know the y-intercept is 0, and then that's a negative slope, so down 1 over 1, down 1 over 1. And here's why it's good to have a good, clear sketch. I can already see those intersection points by doing my sketch. So I'm going to draw this in. All right, so now based on my picture, I can very clearly see that this is going to be my top function, and then this is my bottom. So I'm going to set up just a general integral to get us started here. So I'm going to have the integral, right? I know I'm going to have my top, which is going to be 2 minus x squared. And then I'm going to subtract, and I'm going to be really careful and use parentheses here because it's minus a negative x dx. And again, the reason we did that is because we want our top curve minus the bottom curve. Now, in this case, there's no interval specified, and what we're going to do is we're going to use those intersection points, right? The area trapped in between here is this area here. And we're in between x is negative 1, so I'm going to make this green here, negative 1, and then this point, my x value is 2. So my integral is from negative 1 to 2 of 2 minus x squared minus negative x dx. And since this is no calculator, we're going to go through and do this by hand. So the first thing I'm going to do is simplify this. So I've got 2 minus x squared plus x dx. Now I have to take the antiderivative. So I've got 2x minus x cubed over 3 plus x squared over 2 plus c. And I'm integrating from negative 1 to 2. So I'm going to plug in 2. So I'm going to get 4 minus 2 cubed is 8. So 4 minus 8 thirds plus 2 squared is 4 divided by 2 is 2 plus c, and then minus my lower bound. So I've got negative 2, negative 1 cubed is a negative 1, so this is plus 1/3 and then plus 1/2 plus c. So let's see what happens here. My c's I know are going to cancel out. So this is going to be 6 minus 8/3 minus, what do I have? -2. I'm not going to worry too much about simplifying this right now. Plus 1/3 plus 1/2. So 6 plus 2 is going to give me 8. Then I have -8/3 minus 1/3, which is -9/3, which is -3. And then negative times positive is -1/2. So I get 5 minus 1/2, or 4.5. Now, obviously this was a no calculator question, but I would highly recommend checking it with your calculator once you're done to make sure you've done it correctly. So just as a reminder, right, we're going to go math 9. I've got from -1 to 2 of 2 minus x squared minus a negative, x dx, and I get 4.5, so I know I'm correct. All right, let's go ahead and do number 2. So now this one's a calculator. So find the area of the region enclosed by the graphs of y equals 2 cosine of x and y equals x squared minus 1. And so now we have a calculator. So we're going to use our calculator to get this graph, and then we'll sketch it on our paper. We don't have to worry about being as precise as before because we've got our calculator. So let me clear out what I've got in here. So we have y equals 2 times cosine of x, and then we've got x squared minus 1. So we're going to go ahead and graph. All right, so if I'm looking for the area trapped in between, we can see it's obviously right in that area there. I'm going to go ahead and just shrink my window a bit so we can get a better picture here. All right, so I'm going to go ahead and sketch a picture of what we've got here just from looking at the calculator. So, So I can tell what's blue on my calculator, that's going to be my top curve, and that's the cosine. So I'm just going to go ahead and do a sketch of that. Looks something like this. All right, not a great sketch, but we get the idea. So there's my top, and then I've got my parabola, which is going to be my bottom, which looks like this. So now I've got a sketch of what's happening here. So I can see that my cosine curve is my top, and then my parabola here is the bottom. So if I want to get started on my integral, I know I'm going to be doing the top, so 2 cosine of x, and then I'm doing minus, and again I'm going to put this in parentheses, x squared minus 1, and I'm integrating with respect to x, dx. So again, I'm finding this area that's trapped in between here. Now, I'm going to use my calculator to help me find these intersection points. So I'm going to go back to my graph. I'm going to use second calc. I'm going to do 5 for intersect. I'm going to get close to one of these here. So I'm going to hit enter. Then you can see it's going to jump me up to my other curve. Hit enter and enter again. Now I want the x coordinate because I'm integrating with respect to x. So -1.265 it looks like for my first one. And then we'll do the same thing. Jump over to the other intersection point. And as I expected, it should be the same, just opposite sign, so 1.265. And now we're just going to put this in our calculator. Again, an important thing here is going to be those parentheses. so we calculate the right thing. Two cosine of x minus x squared minus 1 dx. And we get approximately 4.995. All right, so we're going to leave it at those two for now. We'll talk about number 3 when we're back in class, just so we can shake out any questions, and also something a little different pops up in number 3 that I want to make sure we talk through together. All right, thanks for watching, and I will see you back in class.